Okay, guys, so I'm going to go through each of these questions on the extra practice. Obviously, you don't have to listen to every single video. It's really just here so that if you can't figure out a question, you can kind of hear the way that I went through them. So another thing is that YouTube only lets me upload videos that are around 10 minutes long. So that's why I have to do a bunch of these little mini ones just so that I can upload them. So look at the titles just so that you can recognize, what questions that you need help on. So I'm going to kind of just start at the beginning and start with this first question. So the first question says using your vocabulary. So it's very critical within this entire chapter that you know specifically what an altitude is, what a median is, perpendicular bisectors and angle bisectors, and then all of their point of concurrencies on top of that. So there's a lot of information here that you're responsible for knowing. So the first one says find BC if AD is in altitude. All right, and right away you should know that altitudes intersect because they are perpendicular. Okay. So AD is perpendicular to BC, and I'm given a lot of extra information here, but I'm going to focus on the fact that they're giving me that angle. So all I know is that it's perpendicular, which means that this is a right angle, which means that 5x minus 10 is equal to 90. And then you solve, obviously you add that 10 over, you get 5x is equal to 100, x is equal to 20. All right. And then from there, it says to find BC. So you would have to plug back in order to find BC and then add them together. So the length of BD would be 24. All right. The length of DC is 82. And then adding those together, you get 106. All right. So BC is equal to 106. Okay. So the next one looks very similar to the other question. I've only changed one thing, all right? But this question is saying find AD if AD is now a median, okay? And so what a median does is it takes the segment connecting a vertex to the opposite side at its midpoint. So it's not drawn to scale, but just with the fact that we know it's a median, I know that D is a midpoint, which means that those two segments are congruent. So to solve this one, I'm going to have x plus 4 is equal to 4x plus 2. And right away, you guys are going to, whenever you're solving this, all right, realize it's going to be a fraction, okay? So I'm going to subtract the x over. So I'm going to get 3x. I'm going to subtract the 2 over is equal to 2, which means that x is equal to 2/3. Now, we need to plug that back into AD, all right? So we have 5 times 2/3 plus 10. And then just working with fractions, this becomes 10/3, okay? And then I'm going to change that 10 so that it has a common denominator, which is 30 over 3, which is how I got that the length of AD is 40/3. Okay? All right, now the next one, it's giving us that AB is a perpendicular bisector. So one thing that you should recognize right away is that perpendicular bisectors do not have to come from the opposite vertex. Okay, it can be a line, ray, or segment. And there's two components within this perpendicular bisector, and it's the fact that it's intersecting at right angles and it's intersecting at the midpoint. All right, so if you break that apart, you can tell right away what's going on with the perpendicular bisector. So we have to find x and y here. So I'm going to find x first, all right, and x is going to represent the degrees, and it's already being nice to you and giving you that that's a right angle, which means that the linear pair, so this side right here, also has to be a right angle, which means that 4x plus 6 has to equal 90, and then you solve. So you get 4x is equal to 84, which means x is equal to 21. Now, the y's, all right, we just dealt with the perpendicular part, but we have to deal with a bisector, which means that B is the midpoint, all right, which means that these two segments have to be congruent. So if you set them equal to one another, you have 2y plus 18 is equal to 6y minus 14, and then you solve correctly, you're going to get y is equal to 8. Now, our last one, you just need to make sure that you are labeling things correctly because we've been doing this type of question all the way since chapter 1 because we're given that TQ is an angle bisector. So we're given that angle QTX, this angle right here, is 2x plus 10. But then we're given that this entire angle of VTX, so that entire thing, is 5x minus 19. So what we need to recognize, all right, real quick, is that you're only given one, all right, of those two angles that are making up VTX. And because it's an angle bisector, I know that this angle is congruent to this angle, which means that this is also 2x plus 10. So you have to double it, all right, and do 2x plus 10 plus 2x plus 10, which is where you get the 4x plus 20 is equal to that entire angle of 5x minus 19. So then when you solve, you're going to get x is equal to 39. And I believe that you have to plug that back in, all right, to find the measure of angle VTQ. So this angle right here, all right, and you have to plug that in to the 2x plus 10. So the angle, or the measure of angle VTQ, is 88 degrees. And obviously that's not drawn to scale, okay? All right, so that's our first portion. All right, once again, it's knowing your vocabulary, and that comes down to this next portion as well. Only this time you have to look at the notations. So it says, use a picture below which of the following segments or lines are the special triangle segments, okay? So I'm actually going to start with an angle bisector because I think that's probably one of the easiest ones to detect, and it's because you have to be given that the angles are congruent. So if you look here, all right, I'm going to look at this angle YZW, okay? And if you notice that this segment right here is splitting that angle into two congruent angles, that means that segment XZ is my angle bisector, okay? Now, the next three are all actually centered around, all right, this segment right here of YZ, okay? So I actually want to look at this notation right here that's saying that these two segments right here are congruent, which means that P has to be the midpoint. And because P has to be the midpoint, what we're talking about, or which ones we're looking at, are the perpendicular bisector and the medians, okay? So I know that a median has to go from the opposite vertex down to the midpoint, okay? Which means that WP is going to be my median, all right? And then my perpendicular bisector has to pass through the midpoint, and then it also has to pass at right angles. So that means my line M is my perpendicular bisector, okay? Now the last one is our altitude, and all we know is the altitude is it's a segment coming from the vertex to the opposite side, intersecting at the right angles, okay? So that means that YT is going to be my altitude, okay? All right, now this will be the last one for this little section, okay? And once again, it's just knowing your vocabulary. So it says for number 4, if C lies on the perpendicular bisector of AB, then C is equidistant to, okay? So what we know is if points are lying on perpendicular bisectors, they are equidistant to the endpoints. All right, so what that means is that C is equidistant from A and B, okay? Now on B, it says that D is on the angle bisector of angle B, all right? So that means that we are looking at this segment right here, and what we know is that points on the angle bisector are equidistant to the sides of that angle. So you just look at the sides of that angle B, which means that D is equidistant, all right, from CB and BA. Okay. Our next one, all right, says if D is equidistant from C and B, then D lies on it. This is the converse, all right? It has to lie on the perpendicular bisector of CB, and I want you to be specific there. And then the last one says if D is equidistant from CA and CB, this is the converse of the angle bisector theorem, then it has to lie on the angle bisector of, and if you look at CA and CB, all right, that's forming angle C. okay?